Hey everyone, and welcome to another strategic breakdown. Think of the Cambridge 0625 physics exam like a high-stakes space mission. Seriously, when you're launching a rocket into orbit, there is absolutely zero margin for error. Every single calculation, every trajectory, every system check, it all has to be perfectly executed for a successful launch, right? Well, the exact same principle applies to your physics exam. You literally cannot afford to lose marks on easily avoidable errors, sloppy formatting, or, just a basic misunderstanding of core concepts. So today, we are strapping in and preparing for launch. We're going to conquer three of the most crucial and honestly frequently misunderstood topics in the entire syllabus: isotopes, nuclear fission, and nuclear fusion. We're going to deconstruct exactly what Cambridge examiners are actually looking for, how to structure your answers for maximum marks, and the lethal traps you absolutely need to avoid. Let's get started.
Okay, so here is a fact that should instantly grab your attention. 15. Isotopes, fission, and fusion might seem like just a small, kind of isolated section of nuclear physics, but questions testing these specific concepts, along with their multi-stage analysis, they account for a massive 15% of the total physics exam marks. 15%. That's not just a handful of points. That's literally the difference between an A and a C. It's an entire grade boundary, or even two, just sitting right there on the table. If you can master this 15%, you're basically building a massive safety net for the rest of your paper. But examiners know this is a high-value area, so they definitely don't just hand these marks out for memorizing a textbook. No way. They want to see process, precision, and perfect execution. Okay, let's dive into this roadmap for today's explainer. We're going to start with Section 1, the challenge. Then we'll move to 2, core physics principles. 3 is the Peel methodology. 4 is our interactive workshop, and finally, 5, examiner insights and mistakes. All right, Section 1, the challenge. Why raw physics facts aren't enough. Consider two common pitfalls we see students fall into all the time. Let's take a student like Alex. Alex memorizes every historical fact and definition, but then just kind of dumps them onto the page without any real analysis. Then you have another student, Sam. Sam truly knows the physics inside and out, but rushes through the exam completely missing key command words like evaluate or justify. Guess what? Neither of them gets top marks. Why? Well, because knowing the raw facts is only half the battle. You have to know how to apply them directly to the specific scenario at hand. Moving right along to Section 2. Core physics principles, mastering the terminology. Listen, before we can even think about building advanced analytical answers, we absolutely must secure our foundation with perfect, non-negotiable definitions.
Check out the absolute precision required here. Isotopes are atoms of the same element containing the same number of protons but a different number of neutrons. That exact wording is the absolute key to multi-stage analysis questions. When Cambridge asks you to calculate the nucleon number or proton number during a decay equation, they are testing whether you truly understand that changing the neutron count changes the mass, and this is crucial, it remains the exact same chemical element. If you just write atoms with different neutrons, you will lose the mark. You must specify that they are atoms of the same element and have the same number of protons. Precision is definitely your best friend here. Let's move to the main event of nuclear physics: fission versus fusion. Fission is the splitting of a heavy, unstable nucleus into two lighter nuclei, which releases a massive amount of energy. Fusion is the exact opposite. It's the joining of two light nuclei to form a single, heavier nucleus. Examiners demand highly specific terminology here, guys. You cannot just say fission is breaking apart and fusion is coming together. No, you have to use the word nucleus or nuclei, the splitting of a heavy nucleus, the joining of light nuclei. The examiner reports literally show that students constantly lose marks because they say atom split or atoms join. It is not the atom, it's the nucleus. Never, ever forget that distinction. Now for Section 3, the Peel methodology, the physics success blueprint. But before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so we've got the precise terminology down. Now, how do we systematically structure our answers so the examiner basically has no choice but to give us full marks? The answer is the Peel methodology. This stands for point, evidence, explanation, and link. This standardized sequence actually forces your brain to structure physics answers perfectly. First, you make your main point, a direct answer to the command word. Second, you provide evidence. This is the specific data from the graph or the exact formula you're using. Third is the explanation. This is where you show your working and execute the actual analysis. And finally, the link.
where you tie your finding back to the exact context of the question. This logical structure absolutely prevents you from rushing and stops you from mindlessly dumping raw facts. And that brings us to the absolutely crucial method mark strategy. In Cambridge physics, marks are heavily awarded for the process, not just the final numerical answer. This sequence is vital. Identify key elements, apply relevant principles, execute your analysis with clear working, verify the results, and present them in the correct format. Think about it. If a nuclear fission calculation is worth 4 marks, often only one single mark is reserved for the final number. If you deconstruct the question, write down the formula, and substitute the correct data from the given scenario, you secure all those method marks even if a tiny calculator error trips you up at the very end. Always show your process. Let's look at a side-by-side transformation to really cement this. On the left, we have a flawed answer from our hypothetical student, Alex. Asked to explain energy release in a fission reactor, Alex writes, "Fission releases energy because atoms break. Uranium was used in history." See? It lacks command word focus and overloads irrelevant historical facts. Now look at the perfect answer on the right. In this reactor, the heavy uranium-235 nucleus absorbs a neutron and splits into 2 lighter nuclei. This splitting results in a decrease in total mass, which is converted directly into kinetic energy according to E equals mc squared. Therefore, the energy output of this specific reactor increases as the rate of fission increases. Do you see the difference? It's context-specific, it applies Peel perfectly, and it uses the correct terminology. Boom, full marks, guaranteed. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 4, Interactive Workshop. Test your examiner mindset. Now it is time to put you in the hot seat. Put your examiner hat on, and let's see if you can spot exactly where a student is just throwing away easy marks. Here is the Find the Flaw challenge. I want you to imagine a student wrote this rushed paragraph. The process shown in the diagram is nuclear fission. Fission is when things split and make heat. This heat boils water to turn turbines. Read that carefully. Which sentence in that rushed answer instantly loses method marks because it completely lacks specific context and uses, frankly, terrible physics terminology? Take a mental note right now. Is it the first, second, or third sentence? Got your guess? The fatal flaw was the second sentence. Fission is when things split and make heat. Examiners absolutely despise the word things in physics, and make heat is fundamentally vague. You must link the splitting of the heavy nucleus directly to the kinetic energy release shown in the given scenario. Generic words like things will sabotage your method marks every single time. True comparative analysis requires identifying the given information and solving it systematically. On to Section 5, Examiner Insights and Mistakes, Traps to Avoid. We've dug deep into the official Cambridge Principal Examiner reports so you know exactly what traps have been set for you on exam day. Let's rapidly fire off the top 3 mistakes that consistently cost students marks. Number 1, answers are simply too vague. Examiners want specific details and vocabulary, like isotopes and nuclei. Number 2, students forget to check their format and presentation. They don't clearly annotate their working, and they completely forget units. Leaving out a unit is honestly the most tragic way to lose a mark you actually deserved. And number 3, answers are not specific to the context given. Like, if the question is about a fusion reaction in a star, talking about a fission reactor on Earth gets you absolutely 0 marks. Understanding this classic mistake is vital. Just look at this visual contrast. A generic answer fails to address the specific scenario provided. It reads like a boring textbook glossary. But a context-specific answer? It links every single point directly to the given data. It evaluates alternatives, it checks for reasonableness, and it makes recommendations based on the specific graph or table provided. The rule is simple. Never write an answer that could apply to any physics question. Write an answer that only makes sense for the exact question you are looking at right then and there. Let's bring all of this together into your ultimate cheat sheet. This is your complete physics answering system. Rule 1. Command word decoding. Always stop and circle the verb. State, describe, explain, or compare. Rule 2. Peel framework application. Build your argument systematically to secure every single one of those method marks. And Rule 3. Time management matrix. Deconstruct, solve, and evaluate efficiently so you always have time to verify your results and double-check your units. Now, why am I so insistent on this specific approach? Because the data completely proves it works. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers, from a C to an A or a B to an A star. But you really have to train your brain to think like an examiner every single time you look at a past paper. Here is your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want to leave you with a question to reflect on as you go back to your studies. What is your target grade for physics? And be brutally honest with yourself here. Are your answers currently truly contextualized to the specific data, or are they just generic textbook facts? Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. Keep pushing, keep studying smart, and I'll see you in the next masterclass.